It should. There
we go. Okay.
So yeah, just feel free to look around.
So
get used to it. Right now you're in the home page. We're going to specifically be going into differential equations. So
should I go down differential equations?
Yeah.
And then any particular subject in differential equations?
We're just letting you get used to the site itself before.
Okay.
Just understanding what you can do, what you can't do. Any initial comments you may have.
Just scrolling through, looking at the various ideas and links he has. I assume he's got a lot on differential equations. Holy crap, probably more than I learned.
Yeah.
Wow, he goes into Fourier series and stuff too. Damn. Okay. Yeah. Seems like he has a lot of information.
Okay. So we have some demographic questions that we have to ask you as well. Are you currently attending school?
Yep.
What is the highest level of education you have achieved or in the process of achieving?
Master's degree.
Master's degree. How often do you turn to the internet when trying to solve a problem?
All the time.
Have you used the internet to help specifically math-related problems?
Yes.
Okay. Do you remember any specific sites that you've used?
There's one that's called SOS Math that I go to every time for trig identities, and then it's like Math Stack Exchange, I think.
Okay.
I don't know if that's the exact name, but use that
Stack
one.
Exchange, but with math.
Yeah.
Okay. What kind of help other than schoolwork do you use? Have you used the internet for, like
everything in my life?
Okay.
If I have a question, to the internet.
Okay. Have you heard of or used Paul's online math notes before?
I don't think so, but maybe. I mean, it may have come up in a Google search at one time, but I don't think so.
What's your current impression of the site?
I'm gonna click on one of these like basic concept things. I mean, it seems like a pretty standard math site. Like, I don't see any. I think his organization is a bit better than most, but that's about it. I do like his hierarchical stuff at the top.
Okay. All right, I think that covers all the questions. We're going to move into our first design scenario.
Okay.
Okay, so you are studying for your differential equations test.
Mm-hmm.
In the review you had in class, your professor mentioned to study up on Kramer's rule. Use Paul's online math notes to find the definition of Kramer's rule. You are not allowed a search feature.
Oh, okay. Well, I will not do that then. Okay, gonna go to basic concepts definitions, and then search through for Kramer's rule.
Oh, and note that your test is on, or you remember that Kramer's rule is related to the Wronskian of an equation, or of a matrix.
Well, then let's go not to basic concepts. I'm lost without the search function. Oh god. Okay, so higher order different equations, probably not.
So right now, what are you looking for? What are you scanning?
I'm looking for Wronskian. I'm looking for literally the word Kramer. I'm gonna guess that it's in first order or second order, not in the later stuff. Maybe second order because I just saw the word Wronskian. And then more on the Wronskian. Here we go. Let's see if this is. Oh god. Now on the just more on the Wronskian page. Looking for the word Kramer.
Okay.
He has seemingly theorems highlighted in blue. So I'm gonna be scanning for that mostly. Doesn't appear to be on this page, but open up a bunch of tabs and search blue things.
Okay.
See what pops up. Principal superposition. Nope. Not that one. More examples. Nope. Nope. Theorem. That doesn't seem to be it. Okay, so let's look at more on this page. Like, am I allowed to use like these
You are not allowed to use
the navigation.
You can use the quick nav, you cannot use the search feature on the bar.
Okay. Does he have like an index? Just clicking around on his stuff to see if he has
is perfectly fine.
Perhaps an index page. Apparently not. I'm not allowed to use any search feature, so we're just gonna keep doing this click through and look for blue boxes thing.
Okay.
So it was Kramer's rule? Correct?
It's Kramer's rule, and that it is related to the Wronskian.
I am vastly realizing how lost I would be without searching. Okay, so that was in second order. Let's try looking up. Well, let's go back to see if we can find what Wronskian means.
Okay.
Introduced in the previous section. Okay, so fundamental set solution is where the Wronskian is introduced. So now I'm going to scroll through there until I find Wronskian. Quantity is called Wronskian. Quantity and denominator is called Wronskian. And it's denoted as this. And the denominator of what? Oh, here we go. Kramer's rule. Using Kramer's rule gives the following solution. So I found at least a mention of Kramer's rule, but it is apparently used earlier. So
actually, that's what we are looking for.
Oh,
was that right there?
Okay.
So
I didn't know if you wanted like the actual like written definition or just a use of it.
That is the kind of the definition that we were looking for.
Okay.
2x2 matrix. But so some questions about that is, does the layout of the site impede in your finding of the specific information that you're looking for?
For Kramer's rule specifically, yes, in that it doesn't have something with a list of them. Although if I wasn't able to use the search function, so I assume if I could use the search function, it wouldn't impede my ability to find it.
Okay.
But I'm not sure.
Do you have any suggestions? I know that you mentioned maybe an index.
An index of terms would be nice, like you have in the back of a book, and it could just link you to various pages where it's mentioned.
Okay.
Which is effectively what a search is.
Right.
But
so do you have any overall comments on the layout, the difficulty in finding information, anything like that?
With how I went about it, I mean, I was assuming that Kramer's rule was going to be something that he went over. Figuring out what Kramer's rule actually was, I understand why it wasn't in a big blue box. But if I had known what Kramer's rule was to begin with, I think it would have been easier to find the definition of it, or at least how it related to solving the differential equation.
Okay, so would you agree then that if you are trying to look up specific information, this may not be the ideal way to
go about? Definitely not the ideal way to go about it.
Okay, so now we'll go into the second design scenario. You have a homework assignment due at the beginning of class tomorrow. It's now too late to go to office hours, so you look to online resources for help on the problem.
Mm-hmm.
Your homework has you find the particular solution to the following second order differential equation.
Okay.
I'll write it down for you. Y double prime minus y equals 0. Again, it's y of 0 equals 0. Y prime of 0 equals 5. And it is second order linear differential equation.
Okay.
Or, yeah, it gets linear.
And I'm trying to find the answer to
And
this.
just trying to solve that. It's your homework problem. And
Oh, okay. So he has several things in second order differential equations. I'm going to assume most of them are linear, but I'm going to go through basic concepts, then real roots, then complex roots, and repeated roots.
okay.
Let's see if he has something determining this. Oh, look, a perfect example. This one is y double prime minus 9y equals 0. If I show the solution, he shows you can get some solutions here by inspection, which is so helpful. But he has this doesn't have initial conditions though. Two solutions of something then yeah. So we can do in this particular case it would have to be e, I mean just by inspection you would have e to the t and e to the negative t would give us both would give us 0.
Right.
So y could be e to the t or e to the negative t, but then we have to have y of 0 equals 0, so then we'd probably have some terms out front, so you'd have y, assume of t, equals c1 e to the t plus c2 e to the negative t. And then figuring out what c1 and c2 are, we can do with this. So we have 0, 0 for the first prime is going to be c1 e to the 0 plus c2 e to the 0 equals c1 plus c2 equals 0. We have y prime, so we have c1 at 0 minus c2 equals 5, I believe. Move this around, we can substitute stuff or just combine them. If we combine them, we get 2c1 equals 5, c1 equals 5 halves. So that means c0 equals negative 5 halves. Or c1 equals, sorry, c2 equals negative 5 halves.
Okay.
And that should be, once you put it all together, so yt equals 5 halves e to the t minus 5 halves e to the negative t.
Okay. So in this process, how did you just use the website to find your specific?
I found an example problem and applied what
was
it used.
More plug and play rather than trying to learn the theory, or was it?
It was, I mean, it's more, I looked at the example, saw what they were doing, realized that if I need a 1 here and I take the second differential term, with differential equations you want an e to the something typically, and so it's used twice, so the negative would cancel to a positive, and then in the first round you don't have any coefficient out in front here, so it has to be a 1, because the only thing times itself that is 1.
So then in doing this, do you feel like this is helpful to, if you were a student, this is helpful to learn, or is this more helpful as a reference to something that you've already learned?
How I used it then,
or
I would say
from your
something
impression of the
I've
website.
already learned. This though definitely goes through the steps. I mean, the one step where he just says it's obvious and gives the solutions is a bit much, but we are in the second order differential equations. So by the time you went through first order, you'd probably understand that e to the something is an important topic. But if you were just jumping straight in, it wouldn't be exactly the most useful. But as a reference and as something to help you, would be nice.
Okay. Do you have any other suggestions for improvements to this website, or?
For this one, no, that was really easy. At least for that particular problem, if I was trying to solve that.
I have a harder problem here.
Would you like to attempt it?
If you would like to attempt it to see if it's helpful.
Okay.
If you don't mind doing that for us. It's a first order linear differential equation.
Okay.
Y
So first
prime
order linear, gonna go open that section up.
2y over x equals 3. And then y1 equals 5. So y over x.
Okay, and x is a
Function of y.
x is a function of y. Okay, so
Or y is a function of x. I mean,
okay, y is a function of x. Okay. So your first order linear, we're going to assume both of them are continuous function. Well, that's not, that's something else. So I'm on the first order linear differential equation page.
okay.
Looking up how they do them. We have he has a thing at the top that doesn't seem to be of the same form that we're going for, but it also seems that e's are still important.
Okay.
Example 1, here we go. It says, this is the one without an x in it, but I'm just going to go through it just to understand what's going on.
Okay.
First we need a differential in the correct form. He moves all the terms related to y to one side, and then the constant to the other side. I'm going to assume that the x should be on the other side, but I can't do that without putting it next to the y prime. Okay, so then he does that, and then he sees that yeah, you take a e term with a 1.96 on his, yeah, okay. So he has, of the form in the equation he gives above, he finds a value, and then plugs it in. You said x is a function of y?
Y is a function of x. So it's this is dy dx. If that's
okay. So yeah, that's helpful. So y dx plus 2y to 1 over x is 3. So this means that I have a function that I can work with, but I have to put x in the exponential, or 1 over x. Let's see if he has any examples with other terms. He does with x's and y's, with cosine. I'm going to go to the one with just normal t's and y's. So you want to get it in the correct form, which this appears to be almost entirely in the, we have example 4 on this page in the correct form. Because we have constant, we have as many of the y's on one side as we can, and as many of the x's on the other side, which you can't get 1 over, but and the integrating factor is going to be 2 over x. So we have e to the integral 2 over x dx, which is going to be 2 ln of x, magnitude x, but yeah, screw it. Which we need to simplify, which we can put in the x squared into the thing. So if we do that, if we do e to the ln of x squared, that becomes just x squared. And then we know that if we rewrite the differential equation of the form of up here, which is just all the way at the top, scrolling back up, ut times, so it's just going to be x squared dy dx plus 2y 1 over x squared equals 3x squared. Go back down to our example. Oh wait, the y becomes something else, doesn't it? Yeah. Y prime to y x squared. T minus t squared. So what happens to the y?
So right now we're just trying to find
Because there's
what
so
he's doing.
it says rewrite the equation this form with the new form, but then the y drops.
Okay.
Which I didn't realize was a thing that happens, so I'm going to go back up to the beginning and look at where the hell that goes.
Okay.
We're going to assume whatever ut is, it will satisfy the following: ut pt equals ut prime. Okay. Just because that, yeah, that's totally true. So then we place this in x. Okay, so then we have ut times pt was 2 over x, so this is pt, and then ut times pt is x squared times this is u prime t, which is, so we just get x squared dy over dx equals plus xy equals 3x squared. But then the left side is nothing more than the product rule. Okay, I see what you're doing. Which is the same thing as x squared y prime. Okay, so x squared y prime, which is over dx. Your dy over dx. Go back to the example, see what they did. I feel like I'm very close to this.
Okay.
Yeah, so t squared y prime, equals 3x squared, so x squared y equals the integral of 3x squared dt, which is just x cubed. So x squared y equals x cubed plus c. So y equals x plus c over x squared. but we know that y of 1 equals 5, so we have 1 plus c over 1 squared equals 5, c equals 4, so y of x equals x plus 4 over x squared.
Okay.
That's my
That is
first guess.
the correct answer.
Okay.
So do you have any, so when you were doing this, were you looking more at plugging into the equations that it's giving you, or were you trying to actively learn what you were doing?
So as far as actively learning what I was doing, as far as why, I mean, I feel like the moment where I actually got it was where I realized that he's using a product rule here, and that's a way to simplify the equation. Like it's not algebra, but it's like differential algebra, where you're just moving things around. So at first I started with just trying to match things up, but then I think I understand the theory of it now.
Okay. Does the layout of all the text help or hinder you in any way in trying to find out what you were supposed to do?
I mean, I probably should have opened up the example problem next to the definition. That probably would have sped things up a little bit instead of scrolling up and down between them. But if I had them both side by side, it would have been pretty easy, I think.
Okay. Do you have any other final comments, concerns?
Not really. I probably should. I mean, what I should have done is just read it more thoroughly the first time and then gone through. So that's my fault. But what they have there is helpful for figuring out the answer.
So if you were in the student's position, would you go to a different resource that would give you the answer faster, or would you continue to just use this?
I probably would open up Wolfram Alpha and find out the answer. I work better when I have the solution, not necessarily the process, but the solution down, and then I can figure out the process in between, and then I can check that against the solution to figure out if I'm doing it the right way.
Okay.
So I probably would have used a different resource. But then I probably would have used this to get the answer, but I probably would have used this to understand and actually do the problem.
Okay. Do you have any other questions?
Do you feel, well, did it seem like you were kind of guessing at what he was trying to do at any point? Or like there's kind of a disconnect between what he's doing or what he understands when doing the problem and what you do?
And the first one I felt that because he was just like, it's obvious. But I mean, I feel like that's also my fault because I was just trying to skim. I actually read the whole thing, like when I actually slowed down and read that they said, oh, and this is nothing more than product rule, then that was when it clicked. So
okay.
I think he does a good job of actually explaining things.
So he's not lacking any explanation, I guess, as to his thought process or any of the theory that goes behind the more.
No, not really. He gives enough for what you need at the moment. Okay. It seems like. Yeah. So.
Is there any organization of site do you think would, well, besides having the example and the definition right next to each other, is there anything like maybe diagrams or something like that that would prompt?
I mean, he does have diagrams, but I mean, they're more with differential equations. There's not much you can do with diagrams. I mean, he might have like flow charts that might be like, do this step, then this step, then check this thing, sort of thing. And he might have those, but I haven't seen them.
Okay.
But I do like his thing of showing and hiding solutions and stuff like that. That is helpful for if you want to try it yourself without looking and checking your answer.
Is there a different format, like possibly maybe would a video where he goes through step by step and explains along the way be more helpful than saying a text-based format?
I think a video would make me actually pay attention more. But I think the main problem was just I was shooting myself in the foot. But if I slow down and actually read it,
Mm-hmm.
it's very explanatory. I think it's better than a video because you can look at it all at once instead of having to skip back and forth.
Okay.
But then again, if there's a very well done video, they're both great.
Right. Good.
I think we're good to conclude the test.
Okay, cool.
Just
Gonna
press the stop
there.
button up there.